Hi guys. In this video, we're gonna start in chapter 24, which is talking about the magnetic field. And basically, there is a lot of the comparison talking about the electrical field in chapter 20, 20 and 21 and magnetic field. And we can take it and all the time. I try to make the comparison just to make it easy to imagine the magnetic field. I will try to, when I have a chance to compare with the electrical field, I will do that. So the first, for the source of the magnetic field, it is, as the electrical field comes from the chargers, here it comes from the magnetic materials. And it has an electrical field, has two charges, positive and negative. In magnetic field, we have two poles. We call it northern pole, and we call it northern pole, and we call it south pole. So here is the north pole, and here's south pole. So the second pole. The third pole for the comparisons, whereas the similar pole, the similar charge in electrical field, they will be repulsed. And similarly for the similar poles, they will be repulsed as well. So northern with the north, they will be repulsed. South with the south will be repulsed as well. Okay. And different poles or different charges in electrical field will be attract, and different poles will attract as well. So that's the comparison. And we're talking about the electrical field, how the line, what the directions. We're gonna use the same thing in magnetic field. And all the thing over there comes from the positive charges to the negative charge, comes into the negative charge. Here is comes out from the north pole and go to the south, into the south pole. That's the only thing you keep it in your mind. Another thing for the magnetic charge, if we have the magnetic field south and north, and if we cut it to the half, it doesn't mean you cut it to the south and south and north. It doesn't mean like that. Every piece from your cutting, they will generate magnetic field or magnetic materials, where I have north and south. So no matter how many pieces you have, how large you have, you still have south and north pole. Now, comparing with the electrical field, now we're talking about the magnetic field. So the charges create electrical field. Here is the poles, they will create electrical field. So if you put your magnetic here around the iron piece, they will be changing as indication to the magnetic field. How I can identify the magnetic field? Basically using the compass to identify the directions. And all the time we're looking for the south directions as indication for magnetic field direction. So for this case here, I have used 4 compass. So the direction of magnetic field, so here, that's the direction. So this one here. So basically attracted to the south. And this one here, there's no attractive for either way because it is in the center. And this one here, that's the direction for the magnetic field. And this one here, that's the direction of magnetic field. So basically the direction of the compass, the indication to the north, that direction of my magnetic field. That's how I identify the direction of magnetic field. Now let's see from this example here how we identify the magnetic field directions. Here it is north, and we have this one here gonna be the directions out, and north here got for this point it will be has an angle, that's the magnetic field, and here it's gonna be 0. There is no indication to the right or left. Okay, but most of the time you can go to that directions, and from here they're gonna be go inside or toward the south pole, and here they will be attract to the south pole. Now, as a samples, the magnetic field, we give him B as an indication as a vector, so it has a magnitude and it has the direction. Similarly for the electrical field. So talking about the electrical or the magnetic field, it was still dealing with the magnitude and the directions. Let's see what we have. So here's the first one, that is a comparison between electrical field and magnetic field. And here I have positive and negative charges. And here the direction for the charges. All the time comes out from the positive charge, comes into the negative charge. So similarity for that, we put the campus, and the campus here, all the time the sound comes into the south, comes out to the north. And all the time comes out to the north, comes into the north. So the same way that we draw the electrical field, it is the same thing for electrical field or for the magnetic field as well. So this is the way to indicate. Comes out from the north, comes into the south. And here regarding for electrical field lines, because dealing as a vector, here is the 3 point for that. Electrical field line would be all the time it is toward the line, is the tangent to the line of the field. The second point here, as in the electrical field, when we have the magnetic field lines close to each other, that indication for the magnetic field is large. So here, for example, here, close to the pole, where is my magnetic field lines, they are very close, means my magnetic field as a magnitude is greatest. However, in another case, if the electrical field, magnetic field lines, they are away, that means the electrical field will be less. And all the time, all the magnetic field comes out from the north, comes into the south. Similarly for the positive and negative for electrical field. That's the basic stuff you need to keep it in your mind. And here, if to comparing what we have in reality, if we have single bar, and if we have two bars and based in the directions where you put it south and north. So here, if we have, here is the south, here is the north pole, and all the direction of magnetic field, if you wanna draw the line of the magnetic field, comes out from the north, comes into the south. So that's the line how we draw that situation. When we have two power magnetic field, but I have here is the south, north and south. So here is here is the north and here is the south. So it has the attraction, so comes out from the north, comes into the south. So that's the direction of my magnetic field in this particular area. Comes out from the north, comes into the south. Here it comes out from the north, comes into the south. So that's the directions for magnetic field lines. If I put two similar pole close to each other, where is the pole, they will be repels. So in that case, if you see here, there is no interactions, comes out from the north, and here's the north, then it will repels, you're gonna be go to the direction of the south. So that's the magnetic field lines in different scenarios that we have. The only one comment here, all the magnetic field comes out from the north, comes into the south. So here is the reality. So we can deal for the earth, we hear the magnetic field or the south pole. So the earth as well as can consider it as the big magnetic field toward from the north to the south. You had the big magnetic field representation for that. So we have that case. Here's the North Pole. It is not north magnetic field, but talking about this one, it has a north and south field. So that's the magnetic pole. And if you have the compass, they will be indicated to the magnetic field direction to the north. Okay. So that's basically what we try to cover here, just the introductory view for the magnetic field. And we're gonna start it for the next lectures, how we identify the direction of magnetic field, and which we end up with. The magnetic field can be generated if we have moving charge, or another way, if we have the wiring has a current, that current will create a magnetic field. So next lecture, we're gonna learning how we identify the magnetic field comes from the current and how we identify the direction of magnetic field. That's what we're gonna cover next lecture. I'm gonna stop for this lecture for now, and see you next week for a new topic regarding to the magnetic field. Thank you.